Hi, in this video we're going to talk about the rate of a reaction. So what exactly is the rate of a reaction? It's simply the speed at which a reaction takes place. So consider the reaction carbon plus oxygen gives us carbon dioxide. Okay, so when we talk about the rate of this reaction, we're really trying to understand how fast does carbon combine with oxygen to form carbon dioxide. Okay, now there are quite a few factors that affect the rate of a reaction. Okay, so the first factor is concentration. So what this means is that how much of a substance, so let's take for example how much carbon and oxygen are present in a specific volume of the reaction. Okay, so more of them that are present, faster the reaction. Okay, so as the concentration goes up, the reaction rate should go up as well. So that's why we say concentration. The other factor we're going to talk about is the presence of a catalyst. Okay, a catalyst is any substance that speeds up a reaction. Okay, so we'll talk more in details about a catalyst in a different video, but all we need to understand is that the presence of a catalyst, so that's crucial out here, the presence. It doesn't matter how much is there. We simply need to understand that as long as the catalyst is present, a very tiny amount, that should speed up the reaction. Okay, the third thing is temperature. So the third factor is temperature. So temperature essentially for any reaction, as you increase the temperature, the speed of the reaction goes up, which means the rate of the reaction increases. Okay, the fourth factor is the nature of the reactants. Nature of the reactants. And by nature, we're really talking about things like surface area, orientation. Okay, so surface area, orientation. So surface area, for example, imagine there you have a powder versus a block, a solid block. Okay, the powder would have more surface area, so therefore the rate of the reaction would be faster if you are performing the reaction in a powdered form. Orientation is actually a little more deeper. So imagine two molecules. So if I take my two fists out here, and for the optimal orientation for these fists to react, so these two molecules to react to form a reaction form a product would be if they come together this way, where each of these knuckles, they fit into the little crevices out here between the knuckles. But what if this fist was in this orientation and this one came in this? That would not be the right orientation, so they wouldn't fit together. Okay, so therefore the orientation is important. They have to come together in the right orientation. Okay, and then the other concept out here is structure. So what we mean by is what is the exact structure of the compound? Is it round? Is it of the molecule? Does it attain a spherical structure? Is it more oblong? Okay, and all those things contribute to the nature of the reactants, which in turn contributes to the rate of the reaction.